Quite, I don't know. So, welcome everybody. As I already mentioned, I'm Nicolai Parlog, and this is going to be you, me, and Java Next, from Amber to Loom and from Panama to Valhalla. So we have these 4 projects to cover, and Brian Getz, whose name you'll hear a couple of times later, was once told apparently that Valhalla is going to be like 6 PhD theses. So doing some quick math, we have 24 PhD theses to go through in like 45 minutes. So I'm going to be quick. This is not a tutorial to all of these features. You're not supposed to walk out, download the early access builds, and just know what to do. This will more like I want to show you what these things are so you get an impression where they are, where they're going, and then you can follow up yourselves. The slides are at slides.nipavx.dev. On the right-hand side, you will see the link to the talk Java Next. So there are a lot of links specifically on these kinds of slides in this presentation, which links to the project and wiki and mailing lists. I can only recommend if you're interested in one of the projects to take a closer look at those. So let's start with Project Amber. It targets smaller productivity-oriented Java language features. It was launched in in March 17, and is led by Brian Getz. And this is less of a solution and more of a solution factory, right? So Amber is continuously producing new features. And so it tries to tackle these downsides of Java that exist in specific circumstances. It can be a bit cumbersome, tends to require boilerplate, and there are just some situations where the language doesn't allow you to clearly express what you want to do. So then you have to, pull in all of this extra code. And Amber works continuously on improving that situation. And already did quite a lot. So this is reversely chronologically ordered. These are all the things that are already finalized. So specifically, as I mentioned earlier, between 11 and 17, you can see a bunch of things coming in there. And there's like a through line here, which is type patterns, then records, seal types, and also the improvement to switch expressions. So this would be a great time to talk about pattern matching, but I'm not gonna, because there's a great talk tomorrow, probably a great talk. Didn't see it yet, but I'm convinced that Simon is gonna do a good job. The Art of Java Type Patterns. That's gonna be tomorrow from 10:54 to 11:30 in the room, I think 2 doors down. So if you're interested in that, I recommend to look at that talk. Instead, I brought you something new-ish, which let's talk about composing strings. And you'll see where this is going in a second. Okay, so the idea here is that I want to ask a SQL query. And so I have the field of the property that I want to compare by and the name, the last name that I want to compare by. And now somehow I have to get this SQL query and these things together, right? And there are like even more than these 2 approaches, but these are 2 common approaches, right? You want to put a variable value and a string together, so what you do is you just plus them, and there you go. Or you can do the format strings, which is a little bit nicer, but then the %s and this thing is fairly far apart, and you get some SQL injections to boost to this somewhat, as I said, cumbersome code. Wouldn't this be great? Wouldn't it be nice to just say what other languages can do, right? Just give me a special kind of string where I somehow can put the variables just in the string right then and there. That would be better. Still comes with an SQL injection, so still not great, but at least would be easier to get those injections, so that's good, I guess. So the problem is not just SQL injections, right? It's a more general problem. For many kinds of strings that you create that are not just human-readable text, but are specific formats, you need to do escaping, generally sanitizing. You want to validate something that is actually a valid HTML document, or that you balanced all the white spaces in YAML, all of that. So all of these followed format-specific rules. And if first you create a string and then hand it off to some code that you wrote to validate it, that seems a little bit like roundabout. So let's put a pin in that. We probably want to have some format-specific rules being applied here. Then the other thing is, why are we talking just strings? I mean, that's usually something we want to put together, right? But often we don't take the result as a string and we're done with it. We do something else. So first we take the string and the values, we put them together. Well, hopefully we validate and sanitize, and then we get our string. But then often we give that string to some other library or framework to do something with it, to parse it to an SQL statement, or to parse it to a JSON object, or give it to some XML library or whatever. And this seems like somewhat of a detour, right? So first we take the string and the values that we have, then we dumb it down and turn it into just characters, and then we try to like spruce it back up to something that has domain meaning. And this is where string templates come in. So this is just a JEP draft. So this is very early on. Don't bank any money on this, right? So every detail that I'm going to show you now could change, and this entire feature could just go up in smoke. I don't think that's very likely, but it's not impossible. So keep that in mind. So what this does is, we already said this before, the right-hand part, right? I basically already said that would be great to have, and that's called the template string. Right, the thing on the right-hand side, like the select, and I had to split it up in 2 lines because, slides, but still, could be 1 line. And you have already this backslash curly brace here where you embed the property and the value. So that all looks kind of familiar from other languages. This is where the Java part comes in. It has something else. It has more stuff to type. In this case, that's the str dot. And this is actually like the magic part of this entire proposal, I think. So that's called a templating policy. And it takes this templated string here and turns it into an actual string with an asterisk. We're going to come back to that. So this is the step where we get the input, and then we do, in a simple case, the concatenation. So that would be a way to use the string templating policy. You have apparently some variables called description and price and quantity. And then you can just use this to create like a little slip, right? Payment slip, where you have a description of the item, could be hammer, and then the unit and the quantity. So you embed these 3 values. You can do some, you can put any expression there. You can do arithmetic. You can call methods. You can put switch expressions there if you really want to. Like, you have all the freedom. Everything that's a valid Java expression will probably be, you'll probably be able to put that in there. And, you end up with this result, which is pretty neat. Now, the student may spot that it's really hard to pay a fraction of a cent. So that's not great. So there's another templating policy called formatting. So the formatter accepts format strings, right? So now you don't go str dot, you go fmtr dot, and you embed all these things. Like, I want to have 2 digits after the decimal point and all of that, and you get a result that looks very similar, but a little bit different because it has like better formatting. So now we talked about 2 templating policies, string and formatter, but the magic about this is that we can create our own. And for that, there will be 2 new types are proposed. One of them is a templated string, which you can ask a couple things, like what was the exact string that the user wrote out, what's the values that were passed in, all of that. And then the policy is really just an interface, functional interface that takes its input, a templated string, and gives an output, a result. Now, the result does not have to be a string. So, for example, what I could do is this. I could say, look, I have this SQL thing here. That could be something that Java SQL, the Java SQL module provides, but it could also be something that the user implements themselves, or that different SQL libraries, implement differently. So we go with select star from person P, where P is property and this is the value, and then we give that to the templating policy, who will then, do the SQL thing, but also, like, why turn it into a dumb string? We're already doing the parsing, at least partially. Why not just do it all the way and just give you back a statement and be done with it? Let's just ignore the string in between. Same for this JSON example. So you can see I can use it with text blocks, right, by the way. So this JSON example, does the same thing. We have like a text block that embeds name and phone and address here, and then we just immediately turn that into a JSON object and keep using it from there. So that's like a quick preview of something that is being worked on. As I said, it's an early stage. It's not even a finalized JEP, and that JEP is not even targeted, so nobody knows when this will happen, but it's a very, very cool thing that's being worked on right now. Other endeavors that Amber is working on right now is pattern matching, like getting that finalized, right? So there's been 2 previews in 17 and 18 to put patterns in Switch. The 3rd preview is currently probably being proposed for JDK 19. Then more patterns are already like envisioned. We just have to see them end up in the early access builds as well. And then there has been ideas about concise method bodies, like revamping serialization. So overall, there are thoughts, as I mentioned earlier, to make Java more concise and more expressive, right? It's not just about less code, it's about like expressing what you want to do clearly within the language, so it's easier to understand. So as I mentioned, Amber makes it more expressive, reduces the amount of code, hopefully makes us more productive. And now some timeline, because I always get questions about the timeline, and now all my colleagues are here, which is a problem because I'm not supposed to do this. But so these are my personal guesses. This is very important. Now I'm just stepping out of the Oracle booth. I'm going over here. This is just me personally. I have no money, so no suing involved. So these are just my personal guesses, right? They're very rough. But I think that patterns will be finalized, hopefully in switches next year. There's a deconstruction pattern preview. That's the one I linked earlier. Let's hope we see that. Maybe template strings. And then I think the year after we'll be ready to see more patterns. So I think that's like the rough estimate of what's happening. You will see that the current year is missing. Potentially some of this could show up in 19 already, but I wouldn't bank on it. If you want to go dive deeper, there's lots of links here to great talks. The Inside Java podcast is always amazing with these people if they're on. So I linked to a bunch of things here that you can go into if you want to get more information. And with that out of the way, let's go to Panama. So Panama is about interconnecting JVM in native code. Once again, all the links to the project This was launched in July 2014, so that's already a couple years old, and it's currently led by Maurizio Cimadamore. And it really like splits into two sub-projects. The last two are really like tied together, but vector API on the one hand and the foreign memory and function APIs on the other hand are largely unconnected, right? There's no strong through line there. They both deal with like machine or code that's close to the machine. That's why they're the same project, but they're not strictly speaking related. Okay, so let's talk a little bit about vectors and vectorization. So let's say you have two float arrays, and you want to do the square of each of those, right? So you want to square all the first numbers, all the second numbers, add them up, do a minus, and compute C that way, right? So this would be a simple for loop that does that. You go through the entire, and we assume that A and B have the same length, and C has the correct length, and all of that code is stripped out here. But really what you do is you're looping over those, and then you're doing just the math down here, A times A plus B times B, multiplied by -1, and then you get C. Code exactly like that is probably not that common in our code, but first of all, it's very common in code that deals with like graphics, for example, but also stuff similar to that is hidden in a lot of code. And then doing this one by one is actually quite wasteful, because modern CPUs can do this much, much faster. So modern CPUs have so-called multi-word registers, so they could be as large as like to gather like 8 floats or 16 floats in one register. And then they can do a bunch of those computations at the same time. So this is not parallelization across different CPU cores. It's the same CPU core doing, instead of a single instruction on a single piece of data, doing a single instruction on multiple data. So that's where SIMD comes from. Single instruction, multiple data. So you say like, do an addition, here are 8 floats and another 8 floats, give me 8 results. And it's really good at that, the CPU. And so the just-in-time compiler tries to hit that and tries to figure out which of these loops can be unrolled and then auto-vectorized. And if that works, it's great. But it doesn't work reliably because it doesn't have all the information that it needs. This is where the vector API comes in. I don't want to go over the details, like what the species is exactly. We can spot some of the math here, though. So we take something from the array into this vector here, from array A and array B. And then we do A by A, add B by B, -1, and then we put the result into C. Right? So this is like the basic arithmetic that you can spot again here. And this approach allows the compiler, the just-in-time compiler, to reliably vectorize this and make this really fast. So essentially, if you do it like this, could be like, depending on your CPU, 4 times, 8 times, 16 times speed up compared to the loop before. Although, the loop before was simple enough, so it probably would have gotten vectorized anyway, but like in more complicated examples. So the properties of the vector API is that it's a clear and concise API, given the requirements. You might have seen the API and we're like, well, that's not that clear and concise at all. But we have to have some parts in there that actually interact with, how many words can you fit into that register in that CPU. So that's not straightforward to surface it in the API. And I think given that, it's actually pretty clear. It's platform agnostic, so you can write that Java code as you used to, and then you can rely on this being optimized as much as possible on each individual CPU that you're running on. And if it doesn't work, like there's no vectorization in your CPU because maybe running on a very old system, it has graceful degradation in the sense that hopefully it's not going to be much worse than the loop you would have written otherwise. So like there's a potential big gain, and even on constrained systems, you'll probably not see a lot of loss. That was vector API. Now let's talk about foreign APIs. Storing data off heap. So it's a mental shift, totally different topic, right? Now we're going to talk about storing stuff off heap, because garbage collection apparently is wrong, and we know better. So that's why we want to use this API, because we don't want to put stuff on the heap where it's managed by the garbage collector, but off heap for a variety of reasons. The canonical API for that is byte buffer, which is 2 GB limited, and it's not very efficient. And the other version is unsafe, which is unsafe, so not advisable to be used. And then there's also JNI if you deal with calling into foreign code. But that's not very easy to use, and it's not easy to get right or work on all operating systems and architectures. And it doesn't do a good job at figuring out what a C type is, how it's related to a Java type, so it's overall very cumbersome to use, and it's easy to get wrong. And so there are 2 new APIs coming in that work together to overcome these issues. The first one is the foreign memory API. So it offers a safe and performant way to interact with off-heap memory, and you have a couple of classes here that you need to allocate, that you use to allocate memory. And then you can also access and manipulate the array with these 2 classes. And the interesting thing here is that this is much smarter. You can tell these APIs that you have a structure there, let's say a two-dimensional point, and you have an area of two-dimensional points, it's still going to be native offbeat memory, but you can say, look, I'm looking for the fifth point, and then also, okay, the point that's like 2 ins, so like times 5, so that's the offset into the array. So you can use this API to be a little bit smarter and do a little less arithmetic on your own. And you can also explicitly control deallocation across what about different threads? What about different time scopes, like just within a block or for a longer time? And that's very important because that's one of the downsides of using byte buffer, that it's easy to reserve 2 gigabytes, but it's not at all easy to make sure that as soon as you don't use them anymore, that they're returned to your system. And the other thing that comes in is the foreign function API, which is streamlined tooling to call C functions specifically at the moment, although other languages could be plugged in. And it has a bunch of classes here that you would use mainly to interact with that. It rests on method handles, and a very, very important part of that is the toolj extract. So you don't have to create the layer yourself, the adaptation layer. You will have a C file. You will create this Java code that interacts with that C code with method handles, and then on top of that Java file, you will write your own API, but it compiles against an automatically generated file. So as soon as the C library updates, you regenerate that file, and then you will see, well, you get compiler support for which assumptions that are made about the underlying code that I'm calling, which of them are still correct and which of them are not correct anymore because the library got updated, and then you could compile errors, so your adaptation layer can then adapt accordingly, which hopefully makes it easier for projects to adapt native libraries, like maybe in the machine learning space, and then keep them updated, because that process hopefully is faster and more reliable. Okay, so this timeline is not actually just my guess. This is confirmed. So JDK 19 will see another foreign function memory preview. Sorry, the first foreign function memory preview. It used to be incubating. Now it's starting to preview. So that's pretty good. And the vector API, like it's pretty much done, but it needs to wait for Valhalla's value types and primitive types to really shine. And so it will probably be stay in preview until then. So while you can already use the vector API, it can still evolve, and it will at that point when Valhalla comes out actually evolve quite a lot. Once again, more links that you can take a look at. There's an interesting FizzBuzz example that Gunnar Morling wrote, SIMD style, so with the vector API. And then there are a lot of design documents by the Maurizio and the other guys working on Panama that I can only recommend to look at. And that's Panama. Now let's talk about Valhalla. By the way, if you have any questions, we can do that after if we have time. Otherwise, you can just flag me down anytime and talk to me. Okay, let's talk about Valhalla. So it has a very uncatchy catchline, which is advanced Java, VM, and language feature candidates, whatever that means. But we'll see that it's concerned with two very specific, or with one very specific issue. Started in July 2014, so also already been going for a while. It's led by Brian Getz and John Rose, and they're doing some amazing work on that. The basic motivation is that Java is a split type system. You have primitives, and you have classes, references, and there's nothing in between. And each of these sides has upsides, and each of these sides has downsides. I'm going to focus on the downsides here. So the downsides of primitives are that you have no class building techniques, right? Like an int is just a thing. Like you can't call a method on an int. You can pass an int to a method, but you cannot call a method on an int. An int cannot implement an interface and all of those things. But most importantly, we can't create our own primitive types. We just get the 8 that are in there, and that's it. So that's not great. And the rift in the type system between primitives and generics, like that one got wider and wider over time, and one very, very strong step in that direction of treating them very differently was generics. Right? We cannot have an array list over int. So that's really something that having primitives like this made sense in the 90s, but the downsides became worse and worse. Classes are not all great either, so all classes are mutable by default, which means you cannot just talk about a class by the values that it has. You have to always keep a reference to a class, right? Because if the value changes, but it's still the same thing, you have to you have to identify it, how is it still the same thing if you change it from 5 to 6. So that incurs a memory indirection. You have to have extra memory for the header. Every identity-based operation is allowed, like locking and all of that, synchronizing, all of that works on all objects, right? Which is not necessarily needed. And the root cause for the downsides of classes are actually twofold. So for one, they come with identity. Identities were already said, like that's motivated by mutability. What that means, and that's this probably this line puts it best, two things can be equal, but they might not be identical. Right? So if you write new integer 5 and new integer 5, they are equal, but they're not identical. Whereas if you have an int 5 and another int 5, even the question of are they not identical doesn't make sense, because of course they're the same number 5, right? How can they not be identical? So that's what identity means. That two things that are equal by all ways that you can observe are still not the same thing. And that allows synchronization as well, as I mentioned. And then they also come with references. You know, the reference is the memory direction of I just store memory address, basically, and I have to hop through memory to find the actual thing. And that gives you nullability. That's important to understand, right? Like, oh, I can only have null, which is usually a downside, but in some situations does come in handy. I can only have null if I have a memory address that I can null out. If I only have like values, you can have a 0, but you can have a null. And another minor upside is of reference that they protect you from tearing. So if like competing threads writing to the same variable, you can references can protect from tearing, whereas primitives don't, right? So technically, writing two longs in two different threads to the same address, you might observe the first half of the first long and the second half of the second long. It's not a great situation to be in the first place to write to the same long field in two different threads, but still. Okay, oh yeah, the important part was that down there. Not all custom types needs all that, right? So that's what all custom types get, but maybe they don't need all that. And that's where Valhalla comes in and says, well, we try to unify the type system. And we're doing this in basically like four steps, although they're not necessarily like steps following one another. Let's say in 4 aspects. So the first one is we are going to have value types. Value types will not have an identity. We're going to have primitive types. They don't have an identity, and they also don't even have references. We're going to have universal generics, which allow us to put primitives and our own value types and primitive types into generics. But this could still be backed by an object array, which, you know, it's nice to express it that way, but it still sucks that it's not int array, and that's what specialized generics will do. So let's go over each of these in a little bit of detail. So let's start with value types. This will be a qualifier that you can put in front of a class. Here, like you say, instead of class rational number, you say value rational number. And you put the numerator and denominator there. The fields are implicitly final. The class is final. There are a lot of limitations about superclasses. But mostly, this is a regular class, right? So there's a lot of things that you can do. You can implement interfaces, have additional methods, all of that. But it doesn't have an identity. That's what you do. When you say, like, this is a value class, you say, I don't care about identity. And that means some runtime operations aren't possible, like synchronization. That's something that only works with identity, so that doesn't work. It throws an exception. Equals, like the comparison with equals, you know, it looks for identity. Since these don't have one, it compares values. But there's still references. Value types are still references. You still have a null as a default value, and you'll still get protection from tearing. So the good part here is that you get guaranteed immutability, and you can more succinctly express what you're talking about. If you think about, for example, domain-driven design, where a value is like an actual thing, right? You're now able to express in code, this is just a value, it doesn't change, it doesn't have an identity that you have to care about. That expresses that for the user, for the for your colleagues, but also for the just-in-time compiler, which can then apply way more optimizations. And so from one of the documents, I pulled this quote, which says, the JDK, as well as other libraries, has many value-based classes, such as optional and local datetime, and we plan to migrate many value-based classes in the JDK to value classes. So a lot of things that value-based classes, that's not just some word, that's an actual term that's has been established in JDK 8. The Java doc has an explanation of what that means, and it coincides with the exact properties of the values. So you can take away the identity of optional and of local datetime and all of those classes, and all code that followed the rules that were laid out in Java 8 will not see any impact. You can go one step further. You can go to primitive classes. This is what the complex number here does. It has a rational and irrational part. You know, all the same rules that I said earlier apply as well. Plus, you cannot have circularity. Because what you want to do is you want to lay this out in memory like, okay, this is just, in this case, 2 longs. But if then a complex number knows another complex number, then you would embed the one complex number there, and that wouldn't work, right? Because you don't know how deep you want to go. We're going to later see a way out of this. But generally speaking, there is no circularity in primitive types. So just like value types that don't have identity, but they also aren't references. So you never have a pointer to this thing. You only have 2 longs, or, well, that's That's what the JIT at least is allowed to do, right? So the just-in-time compiler can decide what seems to be more performant in which situation, but you cannot rely on having a reference. And that also means that you cannot have null. And that means all of their values are set to their defaults. And that is the reason why a rational number was not a primitive. Because if a rational number would be a primitive class, then the default value would have nominator and denominator 0. But that's an undefined number. And that's really not a great situation to create a rational number that then how to have a field of the value rational number that then immediately lands in like basically NA or not, you know, like an illegal value. That's not great. So in situations where there is no good default value, you maybe want to stick with the value type to use null as the default value. In other situations where if rational is 0 and irrational is 0, you just end with 0, that's a good thing. That's a proper default value that you can use. And the idea is, and the chances look good to achieve that, is that performance of primitive types will be comparable to those of today's primitives. So you can create your own primitive types that will compute, you know, basically if you put something that looks like a long to the JVM, because you know, maybe if you use an unsigned long, then that will perform in additions and everything else just like a long would. Okay, I'm gonna skip the part about primitive boxes. If we have time at the end and you have questions about that, we can take a look at that. But I just wanna skip that now. The interesting thing is that the basic primitives, ints and doubles, they will turn into primitive classes, which means you have now all the integer methods, you now have them on int. So you can actually go 5 dot to string. Or I don't know, integer doesn't have too many interesting methods. But yeah, that's an interesting side effect of this. So that's a language level feature that we see a lot and we interact with a lot. Of course, there's a lot going on in the JVM and the just-in-time compiler, but we see the surface of that. And universal generics are much more below the surface. So for us, the change looks really simple. So what I can do with universal generics is I can just use actual primitives, but also primitive classes in generics. That's all. Like the surface is really just like the tip of the iceberg, literally. A lot of work has to go on for this to actually work in practice, but the more important part on that end is specialized generics, which will then end up having an array list of int being not backed by an object array, because that wouldn't be great really, but instead avoiding that object array and gave me an int array instead. So universal generics means use generics with all kinds of types, references, primitives, primitive classes, whatever, and specialized generics mean if you give me a primitive, I will actually use primitive in, for example, the array list's backing array. So overall, Valhalla is about value and primitive types, putting that together with universal and specialized generics. And the goal here is that we'll have fewer trade-offs between design and performance. To be in fewer situations where you think, this is the code I want to write to make it readable, but either I actually do have to, or at least I feel like I have to write this other code to be more performant. To give you much fewer situations where you have to make that decision, and instead have you write the code that you want with all the performance that you can hope for. It also kicks out a lot of manual specializations, so you probably know that there's a long stream and an in stream and a double stream, but not the float stream, but not a double stream. I always forget which way around. Yeah, right. So at some point, I think they just gave up. Okay, so we have int and long and double, and now that's enough. No more float streams, because that's just a lot of work, right? There's a lot of code in there that has like manually specialized versions. There's also function and then to int function and all of that. So that hopefully they all become superfluous because function from A to B can just be a function from long to integer and then will perform the same way as if you write an int to long function. It will give you better performance. We can express design more clearly, and it will make APIs more robust, because if we routinely pass along values and primitives which are immutable instead of mutable objects, it gives you much less chance of adverse interactions between subsystems. So I think in an ideal world, you would only pass between subsystems immutable pieces of information. So like no change here can ever affect a change here. Yes? Are they, sorry? Well, there are. Oh, do value and primitive types inherently extend object? Yeah, so that's something I want to point you towards these documents that I'm going to show in a second, because that's actually an interesting question that's still being debated. Will there be marker interfaces, and how exactly will they look? Because that's a problem. Like, for example, when you write today, object equals whatever, you know that everything can be an object, so that always works out. Does that still work out with value types and primitives? There comes the wrappers in that I skipped. That you can have a primitive that wraps to basically like an int wraps to an integer. You can have a primitive type that wraps to a reference type created for that primitive. So you can still assign everything to object, but primitive types will not actually be an object. But I recommend to look at the links on the next slide. So once again, some personal guesses. I think we're going to see a preview on value classes soon-ish, and then primitive classes hopefully soonly after. This is the JEP that says all primitives that we currently have could be rewritten in this new form as primitive classes. And then at some point, universal generics, I don't know. And then I think specialized generics are still further down the line. So it feels to me, right, I have the same information that you have. I tend to not ask Brian what his thoughts are because A, he forbids me to, talk to you about this. But also, like, if he gives me inside information that I can't share, that's boring, right? So I don't. I read the same mailing list that you can read and the same JEPs that you can read. So these are really just, as I said, personal guesses. But it feels like specialized generics are like a little bit off. And I think this is where at least like 4 of the 6 PhD theses that were estimated for Valhalla are hidden. At least that's my impression. So as I said, lots of links to follow up on. These are really great. Specifically, the first 2 are really great and actually fairly easy reads, right? Like the first 2, like the Road to Valhalla and the language model, are straightforward reads. You probably shouldn't be super tired, but other than that, I think you don't need any prerequisites. The JVM model, that's too deep for me. I tried to read it and it didn't work that well. But that explains how all of this works in the JVM. So if you know more about that, then that will give you a lot of information as well. Okay, little break. I want to quickly go over a few other things because, the 4 projects are not all that's happening, right? There's more going on every time, every release. There's more reasons to update. So a couple of things that I want to mention, just like I pulled a few things. There are way more out. So for examples, there are lots of APIs that get added and changed. We have an IP address resolution API that allows us to, make IP address resolution non-blocking. That's pretty good. There's a new random generator API. If you deal with random numbers, you should definitely look that up. If you run 2 processes on the same host, you can communicate with Unix domain sockets. They're also supported on Windows recent versions, and so then Java can also take them on. They're much faster and safer than opening a loopback device. They have small additions to all small classes, right, like string and stream and completable future. There's a new HTTP2 API, and all of those see continuous improvements as well. Lots of internal refactorings. There's a couple of usability changes. Since JDK 18, UTF-8 will be assumed by default. It's pretty good. There's a simple web server. There's a command called jwebserver, which you just start to, launch to run a small web server in a local directory to host some files, maybe during testing or just doing demonstrations. That's pretty helpful. That's actually what runs this, right? So this runs in the browser, this presentation. You can see at the moment. There you go, runs in Chrome. And it's a JWeb server that I launched in the directory that hosts these files. You have helpful null pointer exceptions still since Java 14. They tell you something more than, oops, null, crash, but also what was null. So you called that method and that returned null, and so that's what went wrong. Which is probably not that important as a developer because you have access to the source code, so you can look it up. But it's really cool if you have like another line of support between you, or just general like expert users who can then gauge and be like, oh yeah, right, I forgot to set, I don't know, like maybe some configuration setting, and that's where that is null. You have code snippets in Javadoc, which is really cool. So you can have, Javadoc should explain what your API does. You want to put some code in there. You want to make sure that code actually compiles. But if it's just text that you write in a Javadoc comment, you can't. What you can do now is you can put them into a separate file that you can compile. You could even write tests around it to make sure that it actually does what you say it does. And then you pull those couple lines of code into your documentation and be sure that it does what you think it does. It's a packaging tool in there. Since JDK 14, you can use Java Flight Recorder to observe a running machine elsewhere, which is pretty cool. There's also performance improvements, continuous improvements on all garbage collectors, and like lots of little details that would, like you can fill a whole talk with just that. But 2 like larger ones is class data sharing, which allows you to get a little bit better launch performance to applications. You launch them and then you store a certain archive, and then when you relaunch, some of the information that that runtime builds when launching, it can just reuse. Security-related stuff also happens all the time. For example, there's a context-specific deserialization filter where you can say, look, I know that this endpoint only gets serialized classes that have a depth of like the graph, the object graph has a depth of 3. If you give me more than that, something's fishy. You're probably trying to DDoS me. So I'm just going to reject those right out, right? So that's a great thing to look at if you have open deserialization endpoints. And Sean Mullen, who works on security in JDK, has a great blog where he goes over every version's security enhancements. There's also a couple of deprecations going on. So if you were on 11, you should look at these. Biased locking is deprecated for removal, Applet API, Security Manager, and now finalization as well. They're all deprecated for removal, and they will eventually go the way of the dodo. So make sure that if your code uses that you figure out why and how and what you could do instead. And some things were already gone, right? So Nastron is gone, RMI is removed, and concurrent mark and sweep, what was removed in 14. Oh, right, yeah, it's only RMI activation. That is 100% correct. Yes, the activation is missing here. True, good point. I have to remind me later, I have to fix the slide. Okay, so how can you generally, like, if you want to migrate to new stuff, how can you make sure that works well, right? So there are a couple of tips here, which seem super obvious, but it's very easy to digress from that path. So I want to recommend to only stick to supported APIs, and that means if you're not sure how something behaves, don't just try it out, and whatever the runtime does, you're like, okay, that's apparently the documented behavior. It might not be. It might be an implementation detail that can change. So make sure to read the documentation and just rely on what's actually documented. If you have dependencies, which most of us have, try to stick to well-maintained projects. So there's been a huge disparate between projects moving from 8 past 8 to 9 and then 11 between larger open source projects that have been well-maintained, even smaller ones that are well-maintained by a couple of dedicated people, and those projects that have been dormant already for a long time that just didn't invest the engineering work to then make the update. And that will probably or potentially happen again in the future, right? So with the removal of some of these not very often used mechanisms, but still used mechanisms, for example, maybe even refactorings in unsafe, maybe some library that you're using that's years old, that's not doesn't get updates anymore, and that will keep you from updating, right? So one great way to prepare for future updates is to look through a dependency graph and see which of these do you think are really well maintained, and that's great, and which of those aren't. And are there risks? Can you replace them with something else? Can you phase them out? Take a look at that. That's like good in general, but particularly good when you want to update with each version. There's JDepreScan, which you can run, and that tells you which deprecated APIs your code, but also your dependencies are using. And you can build on each release. So when I asked earlier who runs on JDK 18 and no hand went up, like if I hope to have asked who builds on JDK 18, then all the Java 17 hands and probably also most of the Java 11 hands should have gone up. Doesn't have to run every build on an 18, right? Maybe just nightly, that's fine. But really try to invest into that, so to see early on what issues are coming down the line, right? So you want to see, deprecation warnings during compilation. You want to see where test fails, maybe because the method changed behavior that was not, was just an implementation tree that you accidentally relied on. Make sure to learn as much as possible as early as possible. Good. We can skip this. You saw the adoption of all these things. So always using latest is uncommon but persistent. You proved me wrong there. But usually when I ask that, there's always a couple of people like, yes, I'm always running the newest version. And I hope that becomes more common, because I think that's actually like really the best way to stay ahead of the game. Okay, let's talk a little bit about Loom. We got like 6 minutes left, so I might have to skip some details. As I said, you can ask me after. But you also probably heard a lot about this already. So Project Loom is about JVM features and APIs for supporting easy-to-use, high-throughput, lightweight concurrency and new programming models. Launched by Ron Pressler in 2018, and it's super impressive that after 4 years, we're already seeing not only early access builds, but like JEBs, like JEB 425 was recently finalized, right? So this is really like on the cusp of being available. And the idea here is basically to make this process work better. So this process is, imagine you have an HTTP request, you interpret that request, right? Parse JSON, do some stuff there, you query the database and wait for it. And once the database returns, you take the data, process it a bit, send the response. So the JVM is really busy in steps 1 and 3, right? Like you keep your CPU busy doing all that string parsing and whatever. But during step 2, you're just sitting there, nothing happens. So how would you implement the request? There's a synchronous approach, which aligns the application's unit of concurrency, meaning a request. That's your unit of concurrency. You have many of these at the same time, and you want to deal with each of them in isolation. And Java's unit of concurrency, which is a thread, they align Well, in this situation, you just use one thread for each request. That's easy to write and to debug. It blocks the thread on certain calls, and that's actually the problem, because the number of threads, or let's be a little bit more precise, the number of platform threads, meaning the number of threads that you get from the operating system, that's not a cheap resource. And you are badly utilizing them in step 2 because it's just sleeping. So, and that can lead to low throughput, because the number of threads can be the limiting factor before you run out of other resources. And that's the reason to take the other approach, which is the asynchronous approach. You make sure that you're only using a thread when you're actually doing any computation. So you use non-blocking APIs with like futures or reactive streams. This is hard to write, and it's challenging to debug and profile, because the profiler does not know that how you split up a task, and that this task was first on that thread and then a later step was on that other thread. And if you have some code in there that doesn't know about this, that it's supposed to work in this asynchronous manner and just does blocking calls, then all of this effect goes out the window. But the good part is that it does share platform threads. So it has much better resource utilization and can give you much higher throughput, which is what has been so much interest in that. But there's a conflict here between simplicity and throughput. And Loom wants to resolve that with virtual threads. So virtual thread is like a regular thread, but it's a super low memory footprint and very small switching cost. And the important part is, it's not the operating system that manages it, because the operating system has to keep up specific guarantees, because their threads could be used by widely different programs that can share memory and all of that. But the runtime knows much more about what's going on. It's within the same Java runtime. So if it schedules it can do a better job at that. And so the JVM takes over the management of virtual threads. It runs them in a pool of so-called carrier threads. So what we're talking about now is an implementation detail. Ideally, you never notice that by running that. And so what the JVM does is, you get a virtual thread, and then it runs on a carrier thread, which is the actual operating system thread that executes code. And then when you have a blocking call, the virtual thread will appear to be blocking. But what happens in reality is that the runtime says, okay, you're just yielding. I'm going to take away your operating system thread. You can't block that anymore. And instead, I'm going to give that operating system or another operating system thread back to you when the call returns. So if we go through those 3 steps, what happens then is the JVM submits the task to the thread pool, like when step 1 comes in. And when 2 blocks, the virtual thread yields, and the JVM hands the carrier thread back to the pool. So that thread is busy doing something else, treating some other request. But importantly, your code doesn't know and doesn't care. Your code just thinks, well, I asked the database, no, I'm blocking. And that's what all the tools will report. That's what your IDE will report. That's what a thread dump will report. That's what it looks like. At least the new kind of thread dump. And then when 2 unblocks, the JVM notices that, takes the task and the virtual thread, puts it together, resubmits it to the pool, and then eventually you can continue with step 3. So from the perspective of an operating system thread, this looked very reactive, right? I was busy, and then when I blocked, my task was taken away. I was given another task to work on. But from the virtual thread perspective, this looks very much like synchronous code. I ran into a block, I waited, and I continued later. There's an example of how you can very, very easily create 10,000 threads that all sleep. This is obviously not really indicative of what your code is doing, hopefully. But still, it just shows that this, you can run this probably on your phone. Well, if you can get Loom to run on your phone. But still, this takes up basically no resources, right? Virtual threads are super cheap, having 10,000 of them, each of them sleeping for a second. It takes up basically no resources at all. And you can also do stuff like this, where you have 2 tasks that you want to run. Request comes in, you want to run 2 tasks, which you just say is okay, great, let's create a new virtual thread for that task and a new virtual thread for that task. There's no pooling here. You don't have to pool. You don't care. Virtual threads are cheap. You just create more virtual threads, you wait for them to finish, and then you put things back together. So since we did talk about performance a bit, it's important to understand that virtual threads aren't faster threads. Right? You cannot just take your normal computation, put it into virtual threads, and it happens faster. That's not what this is about. A task takes the same amount of time, the same latency from start to finish. That's not what improves. What's improved, because parallelism is concerned with latency. Concurrency is concerned with throughput. And we are using the term concurrency intentionally here. So you're not going to solve the same problem faster. You're going to solve more of the same problems in a shorter amount of time. Each of them individually taking as long as they did before. Because when you're waiting a lot on not CPU-bound tasks, it's good to start waiting as early as possible and as many tasks as possible. Give that workload to your database, to the other services, phase them all out, and keep them busy. Okay, I am out of time, so that's very unfortunate, but you can, as I said, flag me down anytime. We could talk a little bit about use cases, and a very interesting bit is how you can use this capability to create threads ad hoc and have a lot of threads just like as anytime you want some to create new programming paradigms, new concurrency programming paradigm, which is called structured concurrency, not invented by the Loom guys, but still very interesting thing. So there's a few slides on this. But as I said, I'm going to skip them. Thank you very much. So as I mentioned, I'm Nicolai. I'm working for the Oracle team, which has insight.java and, not on the slide, dev.java. Visit those 2 pages to stay up to date with Java. And you can follow, there's also Twitter and YouTube account. It's just /Java. And you can follow me. I'm NipaFX pretty much everywhere. So thank you very much for your attention and have a good conference.